Hi guys, in this video we will discuss a correlation coefficient and regression analysis. Using SPSS. Okay, and now what is correlation coefficient? You must have seen the correlation coefficient in theory. Here we are finding correlation coefficient R between X and Y. Correlation coefficient is a index of relation. When you have two variables, the question is whether this data, the data in X and Y are related to each other or not. Whether if X increases, then Y increases or Y decreases. For example, if X is age, then X increases, and assume Y is your health is decreasing, so they are oppositely related, isn't it? So for two variables there may be relation or no relation. Sometimes the relation may be negative, sometimes the relation may be positive. So to analyze this one, we have an index called correlation coefficient. It's called the Carl-Pearson correlation coefficient, which is always lying between -1 and +1. When R is 0, then it means that there is no relation between these two variables. They are not correlated, isn't it? And when it is positive one or negative one, it is perfectly correlated, either in negative direction or in opposite, same direction, isn't it? Either in opposite direction or same direction. Now look at this example. The data of 9 students, time of holding the breath has been given here. When they breathe normally and relaxing for 1 minute, holding breath after this, or holding breath after hyperventilating has been listed here in this table. We will check whether there is any relation between them, whether one increases, the other increasing or not. Then the first thing is correlation coefficient. Second question here is test the null hypothesis that R is 0. R is 0, then there is no relation. There is no relationship between normal and hypervent. Then the alternate hypothesis, R is not equal to 0. We will test this hypothesis at the significant level alpha is 0.05 using p-value test, isn't it? And you might know that p-value less than alpha, then we will reject null hypothesis. That's it. We will do it in one shot. Let's go to the SPSS. Okay, SPSS. Here already the data have been listed. Go to analyze, correlate, bivariate, move these two variables to the variables box. There is no difference between X and Y. There is no need to classify them as independent or dependent, isn't it? They are considered equally. Now go to options. If you want to mean and standard deviation, select this cell and give continue. Make sure that Pearson is checked, because this correlation coefficient is called Carl-Pearson correlation coefficient. So you need to check this column Pearson. It is a two-tailed test and give OK. In the output page you can find correlations with title. So descriptive statistics, mean and standard deviation of each variable has been listed here. Every variable has 9 cases. Now come to this box, correlations. You will see the correlation, Pearson correlation between normal and normal, same variable. Between same variable, the relation is always perfect, 100% relation, isn't it? That's not our question. Question is between normal and hypervent. Yeah, it is almost equal to 1.966, isn't it? So there is a perfect relation almost between normal and hypervent. It is positive 0.966. And you can see here between hypervent and normal, they are same, because between X and Y, isn't it? 966. This is our correlation coefficient. We will pick it. And significant level two-tailed p-value is 0.000 is almost to 0. When you extend for 10 decimals, maybe there is a number. Otherwise, it is 0, isn't it? So it is a two-tailed. In the two-tailed test, p-value is smaller value. So we will conclude here. What is our correlation coefficient for question number 1? R is 0.996, and question number 2, p value is almost 0, 0, you can write 0 which is less than alpha, so reject null hypothesis. That's it, correlation coefficient using SPSS. Now we will do another question, simple linear regression analysis using SPSS. Okay, here again a pair of data has been given. An estate agency employs 10 qualified sales consultants. The annual expenditure with income and savings in the business of these 10 are shown here. So first row shows expenditure and second row shows income, and you must understand that one of them is x. So for regression, linear regression, we must know the difference between x and y. X is independent variable, y is dependent variable. Y is depending on x, y is a function of x, isn't it? So what is x here? You understand always income is independent, expenditure is depending on income. So expenditure is listed as y and income is x. Okay, now we are going to write the regression line y is equal to b0 plus b1x. That is what here given. Regression line, the line that best fits the data given here. Okay, in this line b1 is the slope and b0 is the constant y-intercept. Okay, the second question, draw the scatter graph of this data and fit the line. Third, if x value is known, can we predict y, whereas b0 b1 is a constant, isn't it? That is case 3. We will do all these things. Finally, testing hypothesis h0, beta 1 is 0 versus beta 1 not equal to 0. If beta 1 0, we conclude that the relation is not linear anymore. Okay, otherwise maybe a type 2 error. That's it. So let's go to SPSS. This data is already here. See, for both correlation and regression, the data should be a scale variable first. Make sure that scale. Okay, and the data view, we have listed the y is expenditure, x is income. In the variable view, you can see in the label y is expenditure, x is income. X is independent variable, y is dependent variable. Now let's see, in analyze again, come down for regression. There is a correlate and regression. Next, linear regression. Here we will find this linear, select this one. Okay, dependent is y, independent is x. Move here. Okay, go to statistics. If you want estimates, confidence interval, you can select model fit, r squared, change, descriptive. If you want anything, you can select. Let's keep it simple. Okay, continue. Plots. In the case of plots, we can pick here the predicted value of y on residuals. This will give you a scatter plot of the residuals and the predicted value of y, which are not representing the data, which are representing the different y values. Okay, this residuals and the predicted values of y. But we have to draw this in xy plane as a scatter dot. That's different one, not representing this original data. Now if you want a histogram, select this normal property plot. You can select, give, continue, and just select it. Okay, in the output page you can go and find what is happening in the case of we have yes, here now it's appearing. Where is it? Regression starts here. In the regression also it shows a correlation, Pearson correlation between two variables, expenditure and income, 0.886. Okay, we are concerned about the beta 1 and the beta 2. So come to the coefficients table. You can see here the histogram and the normal graph that we have checked. This is the graph between expected cumulative probability and observed cumulative probability, and this is the scatter graph for residuals and predicted values. These are not the scatter graph for original data. We will draw scatter graph and draw the line later on this different way. Look at this coefficients column. Now in the column B, constant is B0, the income is x, and x coefficient is slope 1.161. So constant part 17.40, 17.403 and 1.161 is beta 0, beta 1. When you collect these two values, you can write the answer for question number 1. Question number 1, the regression line y is beta 0, which is a constant, 17.403 plus beta 1 is the slope 1.161, the coefficient of x. This is it. Question number 1 is addressed. Now question number 3, if income x is 1100, find the expenditure y. So you can find y is 17.403 plus 1.161 times 1100. You can do this using calculator and find it. Find the predicted value of y. Point 4. It is around 1294.5. So it may fit this data, isn't it? So this is the answer for question number 3. Question number 2, draw a scatter graph and fit the line. Scatter graph for this data, and we are going to fit the same line, 17.403 plus 1.161 x in this scatter graph. So let's go to again SPSS set, graphs, legacy dialogues, scatter dot, select the simple scatter dot, define, and we know y is expenditure, income is x, and nothing else is it. No titles, just to go to okay. Now this is the scatter graph between income and expenditure. For the given data, this is the original scatter graph. These are not the scatter graph of the data. Okay, now double click this scatter graph. You will find a new window popping up here. See, if you browse through this tools, you can find here add a fit line at total. Select this one. Some windows will pop up. We don't need, just close. Now you see the same line, y is 17.4 plus 1.16 times x. This is the line. This is the line that best fits the given data, and that line can be used to predict future values of y for any given x. This is the answer, and you can copy this figure and paste in the Word file. Okay, that is it. Now you can see the answer here. That's it. Now we have seen 1, 2, 3. Next, testing the null hypothesis. We are going to check two tail values of this alpha here in the solution. In coefficients, you can find significant level. For we are testing beta 1, so pick this 0.01, which is lesser than alpha. So reject the null hypothesis. Alpha is 0.01, significant, SIG, isn't it? This value should be picked for income. Income is a coefficient. This beta 1 is a coefficient. This is beta 1, isn't it? So 0.01 will give you beta p value. So for question number 4, p value is 0.001, which is less than 0.05. If not given alpha, pick alpha is 0.05 a default value, right? Therefore reject H0 and accept H1. That is it.